As we have few people, I'm starting the stream. Okay, I'll try to solve. I'll try to solve LeetCode. Should I wait for 10 viewers or should I just go right now? Hey guys. Hey, great bro. I see your top fans. So yeah, some people have asked me to just solve this contest. I'll try to go virtual. Okay, that's fine, right? Yeah, I will first solve fourth one because many were asking about fourth. So let me read the problem. Okay, and yeah, we have 22 viewers. Damn. Are these numbers true or are they like just fake numbers? You should just keep trying, Nagaraju, Madarapu, and then you slowly improve. If you keep trying, you improve. That's how it is. So yeah, let's try fourth. Let's try fourth. Like the video, guys. I have only two. It can be more than 10 easily. So yeah, let me read the problem. It seems short, but 8 points. You're given a cyclic array nums, it's a cyclic array and an integer k. Partition nums into at most k subarrays. As nums is cyclic, so we have to partition it. We are not we are just partitioning it, like divide it into, like break it into nk at most k subarrays. It's at most. As nums is cyclic, the subarrays may wrap around the end of the array back to the beginning. Yeah, we got that. We get that. We have a cyclic array. We just divide it into at most k parts. That's all it is. You have a cyclic ring. You divide it into at most k parts. Okay. Now, what is the problem? The range of a subarray is the difference between its maximum and minimum values. Okay. The range is between the difference between max and min. Okay, let's try. Don't spoil it for me. Okay, don't spoil it for me. Let's try to analyze why it is difficult. Let's try to see what makes it difficult. Is it some brute force, like is it some stupid brute force which is difficult to implement, or is it some nice logic that takes time to get? The score of a partition is the sum of subarray ranges. So each subarray has a range. What is that range? Each subarray has a range which is maximum value inside it minus minimum value inside it, right? The score of per partition is sum of subarray ranges. Return the maximum possible score among all cyclic partitions. Okay, we can do partitions into utmost k subarrays. We have to return that score. It doesn't seem to be a great problem so far. It seems to be brute force, but let's still see. Nums less than or equals to 1000. That also leads us that we can sometimes brute force something. Okay, n less than or equals to 1000. Okay, this is one thing. Now, let's write some small observations. Okay, if k equals to n, you can always make answer as 0. Okay, if k equals to n, you can always make the answer 0. Now you can make at most k subarrays. You can only divide it into at most k things. Okay, so is it always good to divide into k things? Okay, no. More things adds more score to the problem. So probably not. What do I mean? Is it better to just keep it as one subarray? That also may not be good sometimes. See, that also may not be good sometimes. It seems it is good, but that also may not be good sometimes. Why one is not good is sometimes you can make if there are gaps, let's say 1 comma 2 is here and then 10 comma 11 is somewhere, making 1 comma 2 together and 10 comma 11 together is good. Okay, so if let's say we have two subarrays, okay, of the ranges also are there. If the ranges intersect, then merging them is good. So what all we are trying to do is we are trying to look at the problem, we are trying to write whatever we can say, because the question is merging seems always good, right? Yeah, it is good when they are already intersecting. You have this difference plus this difference. Instead of that, if you merge, you will only get this difference, right? So if they are intersecting, merging is good. Else, merging is bad. It's as simple as that. Okay, let's look at two adjacent subarrays. If the ranges intersect, then merging is good. Else, merging is bad. Okay, that's what we have seen. To n, and yeah, here k equals to n. Don't merge anything. Then you have the best answer. Everything is separated, answer is 0. But do you see this statement we can make? What is this statement? If the ranges intersect, wait, it's just subarrays, right? Can't we brute force n square subarrays? The first and the last thing seems to be causing a problem, right? Because it's cyclic. I think if it's not cyclic, then we can do n square easily. Why? We will fix this last subarray, we will find its cost, and then we know previous minimum. Okay, we have again k. We cannot do more than k operations again. So we have n, we have k. So let's try, guys. Don't use ad blocker. Okay, use ad blocker. How can I do that? I kept low. Yeah, maybe it works now. I hope it doesn't mess up the stream. Fine. Yeah, it didn't mess up the stream. Where are we? Yeah, here are we. So you have these two ranges. If they are merging, then if they are intersecting, then merging them is good. If they are not intersecting, then merging them is not good. Okay, we are just seeing adjacent subarrays. Can we see three subarrays? Okay, these two are not merging, these two are not merging. Okay, so now we can say because at most k things. So 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 if you look at optimal, if you look at optimal, which is less than or equals to k subarrays, you can say optimal with minimum number of subarrays. Okay, let's look at optimal with minimum number of subarrays. Okay, why am I looking at optimal with minimum number of subarrays? Because you can say that no two adjacent subarrays intersect. Right, this we can say. Why? Just the same point. If they are intersecting, uh, you could have merged them and formed more optimal ones, likely. uh, Even if it is not reducing the cost, it will reduce the. Oh, we want to return maximum possible score. Damn, I thought I was thinking about minimum possible score, but now we want maximum possible score, it seems. So guys, let me rethink the problem. Okay, it's maximum possible score. What we want is maximum possible score. So now we have to think again. what we want is maximum possible score. See, we want maximum possible score. Okay, let's think about that now again. So keeping them together, you can have max minus min. So see, if it is about maximum, we have to find upper bounds. Okay, we have to find upper bounds. What I mean by upper bounds is we show that answer is less than or equals to our procedure value or brute force. We either find upper bounds or we brute force the structure. But still, even to see the structure, we have to see. Sometimes we have to see for the upper bounds. What I mean upper bound is you show that answer is less than or equals to this upper bound, and then you form that upper bound and you prove that this is the maximum. Otherwise, you cannot prove that that is the maximum, right? So let's think about the problem again. Mm, answer is greater than or equals to max minus min, taking one subarray. But this is lower bound. You have to understand that you're trying to show answer is greater than or equals to this. But what actually matters for us is these things, because when we finally find prove that this is the maximum, we show okay answer is less than or equals to this and this is possible. That's how we show that's maximum. Okay, so this we can say taking one subarray, this is possible. So now we have to think. If you look at if you look at everything, if everything is like this, okay, I mean if everything is like 1 2 up to so on max, then whatever you do, I don't think you can get better, right? Whatever, however you divide them, it will be this minus this plus that minus that plus that minus that plus that minus that. So here answer is less than or equals to max minus 1. So you guys can observe that we are using here, we got a upper bound. See, upper bounds are beneficial because here whatever you do, or if you can capture what is happening here in a general sense, maybe then we can capture a good upper bound, and then we can probably solve the problem. I know I'm complicating it, but yeah. Yeah, long time no see. Are I think Niketan Sinha or someone else has asked me. Yeah, Niketan Sinha. I don't know. Yeah, what I mean is, if they are in a line, even if you divide them, probably this subarray max minus min and plus this subarray max minus min, uh, they keep getting cancelled, right? Okay, that's fine. Maybe solving in context is difficult, but let's try to solve the problem a bit more. Uh, the thing is, if it is about brute force, we have to approach okay this can be brute force, maybe this n into k works, but before that we have to work on the problem, right? It doesn't matter how many people has solved, we have to focus on the problem and try to work on the problem. So if you try to see this case, if you subtract this minus this plus this minus this, all of that will be less than or equals to max minus that, because it's increasing, strictly increasing. When you when you split them into something, okay, if this and this are involved, max minus 1 you will get. Damn, okay, you can get more than that. Plus max minus 1. So let's just this be m. In this case, you can get m minus 1. We're trying to see some case and try to generalize the solution, because whatever the code we write, that should work for this case also perfectly. So this is not bad thing to do when the problem is difficult. Plus let's call this like x, maybe whatever is in front of that, x minus 2. So this is I think this seems fine. Why? Even if these two are connected, then you have m minus 1, and in between everything they are splitted, right? In between everything are splitted. So if you split everything in between, now you can say this minus this plus that minus that, that minus that, at max will be x minus 2, right? It's like a chain, this minus this plus this minus this plus this minus this, this minus this. So even if you sum all of them, it will be less than or equals to this minus this, right? So if you see well, it is overall it is some mi minus a small mi plus mi minus So it is like some value minus some value. Let's say x1 minus y1, max, I will call max by x1 and min by y2, x2 minus y2 plus x3 minus y3, up to so on. It is maximum of this thing, of this value. I'm trying to simplify that. I'm trying to make it a bit simpler. But what is the constraint? X1 and y1 should come. See, the fact that x1 is maximum is what is best among one subarray. So I'm generalizing the problem. I'm removing that is x1. I'm removing that this is y1, but I'm telling because y1 being minimum is best, x1 being maximum is best. We have to do something like x1 minus y1 plus x2 minus y2 plus x3 minus y3 plus xk minus yk, such that x1 comma y1 occur, and then x2 comma y2 occur, and then x3 comma y3 occur, up to so on. This is what we have to, both are equivalent problems, because once you fix the subarray, uh, making x1 to maximum and y1 to minimum is anyway the best one, right? So this is what it became slightly. I don't know if it helps us or not, but it is about this summation. Are there any lower bounds for this summation? See, even in this case, if it is if if k equals to 1, answer equals to max minus min. What if k equals to 2? How do you solve the problem then? See, the problem involves some structure to the optimal, and once we capture that, probably we will brute force on using that structure. Like if we know how to brute force that structure, if we can know some points on the optimal, then we maybe then we will brute force the structure like dynamic. I don't know, I don't like to use dynamic programming, but I like to use dynamic programming, but because of how you people use it, I don't want to use it much. Okay, so what I'm trying to see is we have to understand the structure. For that, what we can do, we can see, okay, what happens if k equals to 1? You have to return that. Your code is a generalized code, but it will return max minus min for k equals to 1. What about k equals to 2? Then you have max minus min. Can you get more? In this case, we are able to see that we can get more, right, at some time. If you see it in this way, can you add something, subtract something, add something, subtract something, and and how do you maximize this one? Wait a minute. The x1 and x2 occur. Okay, x1 and y1 can be changeable, but they both should occur before these two, and then they both should occur. Okay, what if it is not a cyclic array? How difficult then it is? Then you have, then you can solve. Okay, if it is not a okay, brute force probably can we can do it in n power 4 or something, because the structure is cyclic subarrays, right? You will fix, brute force might be n power 4 or something. Okay, how? Maybe you will fix the front and the last subarray, how much they combine. That would be n square, and then you have this in between subarray. Now you have to solve the problem in, for this in between thing, you have to solve the problem in, we can try for some more time, okay, because it's a difficult problem as you guys are telling. Can we do brute force on position of partitions and max minus min in range of current partition and previous partition? I don't think this will have too much logic. We have to just simplify something and then we have to brute force it somehow. Let's try to see, guys, how we will solve this problem. We are surely solving this one, but let's try to see. At least let's try to get everything that is logically there in the problem. Okay, I will try to understand that again. Okay, if we can brute force using some n power 4 or some things, that we can say. How? if it's not cyclic itself, you can try to fix one dp, which is number of you can fix the last subarray. You have its answer. You will make sure the previous subarrays will be less than or equals to uh, n times of k minus 1 or something like that. So you can compute n. You need n into k states for each prefix. You want n into k states. If it is not cyclic, you want n into k states. K states will just say uh, n into k states, and then again complexity. I'm just brute forcing the last length one. Then it is n square times k. If not cyclic, you can do this. What is this? Uh, let's say this is the array you want to compute. You will fix the last partition. You will find its answer. You want less than or equals to k. So for this, you want answer of previous things less than or equals to k minus 1. So if you find for all I, for all k, and then I'm using n again, O of n thing. Maybe this can be simplified. Maybe this O of n can be simplified somehow. But we have to solve the problem. This problem should be logically solved. We have to logically prove that whatever the structure we brute force finally, that is the optimal structure. We have to prove that. So the thing is, yeah, what I mean by upper bound is, if I define something that might be upper bound for any partition kind of. So okay, we have to maximize the value. Let's see about intersections itself. If two ranges are intersecting, then combining them would be bad. Okay, then combining them would be bad. If two ranges are intersecting, can you get an upper bound for this one? Okay, one upper bound would be max of minus min half. See how upper bounds are useful. Max k things minus min k things. This is an upper bound, right? This is for sure an upper bound, right? See, now you guys are able to understand why I say about upper bounds, because upper bounds restrict any test case, because this is an upper bound for sure, because this is our problem. And if this is possible in some test case, then that should be the answer. You cannot escape that. Yeah, bro. Yeah, Mohit. It's Sunday, right? Yeah, the new job. I have even worked little bit just before this thing, and then I came here again. I'm not getting time to work though. I'm not getting time to. I'm in home. That's why I'm not doing anything. So, guys, do you see that this is an upper bound? Max k things minus min k things is an upper bound. Do you see this is an upper bound? What I mean by upper bound is, now, I mean, we have to maybe, okay, this is an upper bound, but this may not be the strictest upper bound. Strictest upper bound is the answer, because strictest upper bound is the answer in the sense like this this can be strict for some test cases. Maybe for other test cases, this may not be strict. So strictest upper bound is the strictest upper bound is the answer. But yeah, so when is this possible? This is an upper bound. So let's try to see a test case where this is possible. See, I'm able to do work. That's not possible always. But let's look at test cases. Let's look at, maybe see on my LinkedIn or somewhere where I have posted where I'm. Let's look at test cases where this is possible. Okay, so if you have it like max, okay, let green be max k, let red be min k. Okay, if you somehow have green red green red green red green red green red, then you are done. Other things be blue. You don't care where blues are. In all these cases, the answer is this. See how upper bounds are useful to see the structure of the problem. For all these cases, the answer is max or things minus min or things. Do you see that? I mean, we are able to get an upper bound by also using k. We have brought in k into picture somehow. If you guys see that. In all these cases are so many, right? Because now you can jumble all green things as you like. You can jumble all or things as you like. It's still cyclic. And still the answer is, I think even the jumbling can even be RGGR, but it cannot be RRGR G, because then you cannot pair this R with this G. So it's like even this is it should be able to we should be able to pair R comma G and G comma R in all these cases. The answer is that. So one thing, bigger subarrays are always good. Okay, that we can say for sure. I thought about minimization problems, so I was confusing. Uh, this is for minimization problem, not minimization. Okay, yes, it is. If you can keep, no, it may not be good, because if you divide into two things, maybe they both will reduce the effect, right? Even for maximization, it's not true, because let's say they are like this. You have this minus this, okay, but now if you divide, it will be this minus this plus this minus this, then the in between might be lost. I'll remove people if they okay, got it. It's just my friend, I guess. mm, yeah, it's not that easy to understand. You have to try slowly. You have to try to understand slowly. So where are we? mm, so but do you guys see, wherever for all these cases the answer is, see, working on upper bounds may sometimes be bad when there is a brute force solution, because you should not spend too much time here by trying to find something nice in the problem when there is nothing nice in the problem. Do you see that? But this thing is always true. Let's say, suppose, because taking everything may not be good always, right? Because if you take anything, the answer is zero. Uh, but this will always play a picture. Suppose somehow the optimal is having k minus 1 things, okay, and if uh, gk minus 1 and rk minus 1 follow above structure, then that's the answer, right? So can we find what z follows this pattern? Can we find what g of z comma r of z follows this pattern? Then we can at least say, at least if you are picking that many z things, the answer is this one for sure. Going to any lower is bad. We have to only think about the upper things. Do you guys agree to this thing? Hi Mikoyan, you paid for subscription and I'm not doing any member related things. Sadly, I'll try to help you in some way, but yeah, I'll be GM. Don't worry. Yeah, you have to wait. Let's try to see. I don't know about that H10 YouTube. I like seeing people's channels. What does he post on YouTube? Nothing. Bro hasn't got any content. Daily shots. Such lies. Learn with me. Where are you? Breakdown of big videos. Just keep scrolling. Where? You have gotten cool template compared to mine, for sure. But where? I don't have that. Maybe can I just borrow this one somehow and add that to mine? Uh yeah. So let's try. Some people are getting mad because yeah, you guys should be like chill like Mikoyan. He's paying me for no reason and then see. Yeah, that's great. Do something. Do something is always great. Uh yeah, I'll try until end. Like even in last contest, I was trying until end. So we have 59 minutes. Let's see this one. See if some jet follows this pattern. Jet equals to one follows for sure. Jet equals to one follows this pattern. Why? You have maximum green and minimum red, green comma red, right? So if we can brute force, we can binary search to find what we can binary search to find maximum jet that follows this pattern. This is surely possible. We can binary search to find maximum jet that follows this pattern. Why? How? Because if some jet follows that pattern, you have RG or something like that, you can probably remove the minimum two things and still form the pattern. Probably. You can remove minimum these two things and still maybe you can form the pattern or maybe not. What about this? Can we do binary search on that or no? Okay. Maybe even if you don't do binary search, we can brute force itself and find what all jet will satisfy that. Right. So we know if we are taking less than or equals to jet things is bad. So we can find what is the maximum jet using binary brute force itself. But is it even helpful? I mean, if that jet is k, then we are good. If that jet is k, somehow we are good. But if that jet is not k, is that even helpful? Do you guys get what I'm trying to do here? Damn. Who is Mikoyan? I know it's his name, but I'm thinking because of fighter jets, is it some reference to something? So my guy doesn't take any negative things onto him. Now he'll more subscribers than me. No, I'm happy for that. That's great, bro. Okay, let's try to think. Okay, do you guys get what I mean till here? Do you guys get what I mean by maximum jet that satisfies this or GG or that thing? A bit. I mean, we don't know if this jet helps at all. But then this is like if this pattern is possible, you can say for sure taking that many G's is good. See, let's try to see. Maybe that's the answer. We never know. Maybe that's the answer. Maybe taking more than this jet is always bad. We don't know. Maybe it's bad. So if it is actually true, maybe then we can actually try to think about that. Let's see for this k equals to 2, right? Can we make 3 1 3 2? Yeah, we can make green red. Sorry, green red green red red green green. But then these two we can map. These two you can map. Okay, k equals to 1. You can pair 3 comma 1. You're done. K equals to 4. You cannot get 4 pairings for sure. You can at max get 2 pairings. Okay. Sometimes g can be equals to r, but that is bad for us. Why would we do that? If g equals to r, we won't like that, right? I mean, if both are the same things, instead we could have not taken that itself and we could have made lesser subarrays. So we can also say we will ignore the cases where g equals to r. Okay, if g equals to r, we could have just not taken that at all, right? Because we are not partitioning. If x1 equals to y, xi equals to yi, we just remove both of them. Less than or equals to k things is still holding true. So for k equals to 4, we have n by 2 things that's possible itself. That is always the biggest we can get. Okay, so now I have to see, is this binary searchable is one question. Otherwise, is unfind max jet for which above pattern is possible. Now our question is, can there be something which is jet plus 1 that doesn't follow above pattern but has higher score? That's our question now. Do you guys get what I mean? Jet is the maximum value for which the RG pot is possible. We are trying to get choose maximum R's and minimum G's. Sorry, maximum G's and minimum R's, K maximums, K minimums. I won't leak such info, personal info. I'm just joking. We'll take maximum R's and minimum Z is something for which this is possible to pair them. Okay, I'm just defining Z to be something for which it's possible to pair such things. Okay, what do we mean by that? I mean, because if Z equals to K, you can pair maximum KGs and KRs, then you have solved the problem. But maybe you cannot pair them. That's why I'm trying to see something smaller for which you can pair G's and R's. I think this problem may not be that difficult because you have to pair adjacent red and greens. This can be done greedily, probably, right? This can be done greedily, probably, right? Uh, I'll be back in a minute, guys. Hello, am I audible? So, guys, we have to think. I have contest at 5:30. I think at Coder I have to register for that. So we have to think. Maybe this jet is the answer. We never know, right? Should we submit such a thing and see how well it performs? Now, bro. Mm, yeah, I'm getting charged. I'm getting charging now. See, it ons automatically. Voice. No, Nellore City is also there in that. Okay. This I want to register and give at 5:30. When is it? 29 minutes. So, guys, we have 29 minutes. Uh, so, is the maximum jet, is that the answer? It may not be. We have to now think about a case where z less than or equals to k, right? If z equals to k, that's the answer. If z less than k, is it possible that you can split them into more and get something better? Think about that. Is it possible that you can split them into something and get something better? Think of that. Why is z plus 1 not possible? Yeah, I think we can see some other answers, right? Let's say these are in increasing order, a1, a2, up to so on, a3, up to so on. I think this should be brute force, guys. There are nothing here. There is nothing. I think spending more time on here is bad. I'm telling this and this, right? Because k is there. But maybe we can add z plus 1, which is like a4 here and not a4, like a6 here and a7 here. These are in sorted order, let's say. Maybe you can add these two things extra along with this z. So maybe this z plus 1 is possible, right? This gives more score. This gives more score, right? Because these two things are also getting added. Because these two things are also getting added. So let's say what we choose finally. Okay, what we choose finally. Let's say we are choosing finally some G's, some. This is sorted order. Let's say some R's and some G's. Can we say that these R's and G's doesn't intersect? Can we say that these R's and G's doesn't intersect? There need not be last G's and there need not be first R's, but can we at least say these things won't be intersect at all? Think about that. What if? What I mean by that is, can we have some R here and then can we have some G here like that? Uh, would this be optimal? I think it's difficult. I'm not able to solve it. We have to find something. We have to find something in the structure. It's being simple, but then we have max minus min. See, we have the structure is like, if this is possible, the answer is that. If this is possible, the answer is that max this minus minimum this. But if that's not possible, what would be the best thing? Can we just say at least these things won't intersect like that? Means uh, maybe we can always move them into this side. Maybe just think about that. Let's say some G is missing. uh, okay, first think about this thing. Is this bad? You have some segment where G is smaller and then its R is even smaller, but then you have some other segment. If they are adjacent, it's impossible. Why? You can merge them. No, you cannot merge them. Maybe it's still good. Okay, guys, I'm not able to solve this. Let's end this. I don't know. Like, I'm not very good at like brute forcing. If there is not something nice, I cannot find it. If there is something nice, I should be able to find it. But the score of the partition is sum of subarray ranges. They say it's cyclic, max minus min. In all the cases where you can group large k things and smaller k things, the answer should be this. What is an upper bound that always persists? It's not even utmost k. I think making it bigger, is making it bigger always good? May not be good, right? Here you cannot make it bigger, you cannot make them bigger, and then if you have 2 that may be bad. But maybe it is possible in some other sense. Okay, uh making it more number of things, is it good? I'm thinking about 1 2 3 4. If this is one thing, making it 1 comma 2, making it 3 comma 4 is bad. But making it 1 comma 4 and making it 2 comma 3 is good. So is that always possible? Is that always possible? Can you always make more number of things and make it good? I mean, more number of things such that they have two things. Okay, if they're having one thing, that becomes zero again. So you have this thing. Can you split something and then make these things bigger? But do you guys see that? The problem is about alternating this RG, GR, GR, RG up to so on. What I have told right here. The problem is the sequence is you have to put RG, GR, GR, RG or something like that in a cycle, such that these things will be -1 and these things will be +1, and you want minimum answer. So the problem is you put some +1, you put some -1, and then you put some -1, you put some +1, -1, +1. You can put many zeros in between. So number of -1s you put, number of +1s you put, total should be less than or equals to k, and you want maximum sum. So this is the problem. That's what I have written here. And for this problem, I'm trying to see what would be the possible values. So our question was, is it always good to to make number of +1s and -1s more? It doesn't seem so, right? So you have these things. Can you add one more +1 and some one more -1 and make it bigger is the question. And what is this pattern? You want, you cannot have three -1s or three +1s in a line. This is the pattern, I guess, right? Is this the pattern? If you cannot have three -1s or three +1s, can you then pair always? Because let's say you have one, you have -1, you have one, you can pair them. Okay. And then if you come from here, even if it is -1, the next thing cannot be -1, the next thing will be 1. Even if it is +1, the next thing, if that is +1 and then -1, let's say you're pairing these two and then +1, you have to pair these two. See, this is impossible again. But number of +1s and -1s should be equal, right? So is this the constraint? You cannot have three -1s or three +1s in a line. I'm trying to understand the structure of RG, GR, BR. I mean, this. We're tr- that is good, but see, you never know. The logic I'm using already may be very well correct to the problem, because I'm able to analyze it very well. See, one -1s. I'm trying to think of it a bit more. Like we have still time, but I have a code contest. The thing is, it's if there is something nice in the problem, I will capture that somehow. But yeah, let's try to think about this very well. Can you have if you cannot have three -1s, you cannot have three -1s, then if you have three -1s, either these two will get paired or these two will get paired. That is wrong. Okay, if you don't have three -1s, if you don't have three -1s or three +1s, then can you pair them? This is the problem, right? If you don't have three -1s or three +1s, let's just take two things. Okay, you can pair them. Let's just try to look at these things. Yeah, you can pair this and this, you can pair these two in this way. Even if it was this, you can pair them. You can pair this and this, you can pair that and that. So let's look at linear thing itself. In the linear itself, if there are no three minus ones, okay, let first one be plus one and the last one be minus one, then you can pair these two things and then by induction it's done. Let's say all linear things can be paired in that way. All linear things can be paired uh, inductively, because I think all linear things whose sum is zero can be paired probably. If you have plus one, that is true likely. Let's use it via induction. Now, for sure, minus one is here or minus one is here, because if you have one here or here, that forms three things in a line. So minus one will be here. So you will make these two things in a line, and then you will again have its smaller number. So that's true. That's true. Inductively, that's true. That's true that you can always pair them up, because this sum is zero, number of plus ones and minus ones is zero, and you're able to pair these things. You can pair these things inductively. So it's true for linear itself. If it's true for linear itself, it's true for linear, but cycle is coming here. If you have one and minus one, this is coming in terms of cyclic induction. So now let's apply this. Ah, what about 1 minus 1? But then I'm applying wrong induction here. I'm applying sometimes linear, sometimes cyclic. Because here I'm taking cyclic and then I'm taking linear. Right. So let's look at linear. If it is 1 comma minus 1, it may not be possible to pair these two things. Yeah. So we need both linear and cyclic. But is it true that you can always somehow pair them if it's a cyclic thing without 3 plus 1s? Just look at them. You have 1 and 1. Let's say you have two 1 and 1s. Okay. Let's look at, you have 1 and 1 somewhere. Let's say if it is all 1 minus 1, 1 minus 1, 1 minus 1 in the cycle, then done. I'm trying to prove that if there are no three ones or three minus ones, then we can do that. If you have 1 1 somewhere, this must be minus 1, this must be minus 1. So you can group them and you can group them. Now it became a bit linear. But now, again think about it. If you have 1 1 again, you'll have minus 1 minus 1. But see, you cannot have 3 minus 1s again. You may have plus 1, but then you must have minus 1. Then you can do some other pairing probably. You pair these two, you pair these two, you 1 minute. It's being impossible here. You pair these two, you don't have you don't have them in a line, but you don't have 3 minus 1s, but still you cannot pair them. Because these two minus 1s will make sure that these two will be paired and these two will be paired. But these two plus 1s will make sure that these two must be paired and these two must be paired. So structure is not just this one. Structure is more. There is more to the structure. What is that? What is the structure now? You take any two adjacent things, they cannot be colored same. Sorry, they can be colored same. Can we understand the structure? It's just RG or GR, RG or GR, RG or GR, RG or GR. Why is this structure so difficult to understand? Wait a minute. I told this is impossible, but here the size is not even. So leave that. Is this possible? These two should be paid, these two should be paid, these two should, okay, maybe the size should be okay, maybe it's possible, maybe that's the structure. So now the problem became, we have to brute force this structure. Let's assume this one. Okay, See, it should be greedy, right? If you can pair these two, you pair this one either with this, or you pair this one with the previous thing. Two possibilities. So let's say you pair these two, and then you should be able to pair these two, and those two. I mean, this problem is not too complex. This problem, in the sense, the problem of plus one and minus ones. Yeah, one is something that became plus one in somewhere. Nah, bro, I want that coded. It's a rated contest for me. I have to eat something in between. I'm ending the stream, guys. See, we have gotten very good ideas. You have to understand that. Is this truth? Ask yourself. Is this true? All it takes is not having three ones together or three minus ones together. Is that true? See, we have seen good ideas. That's enough for the stream. We have seen good ideas. Maybe if I solve it, I will again stream it. Bye. I'm ending. I have to eat something and then I have to give the contest. If I solve it, I will come back. That's what I told. I won't leak any info like that. Bye, guys. Give a code.